Hey guys, and welcome to this session on Flutter development. So let's start off by talking about inGenius. So inGenius is the flagship event of PESU ECC, and it's particularly a hackathon that allows you to demonstrate your ideas and build them up in front of a panel of judges, and you get an opportunity to win exciting prizes as well. So uh, and this year we have switched to the online mode due to the ongoing lockdown situation. And our sponsor for this event is Amigos. So before we get started, I'd like you guys to join this this Slido site over here with the code 23326. This will be used for a couple of questions that we'll have in the seminar. Okay, so now let's get started. So before we start, there's a question that I'd like to ask my viewers here. So now, how many of you, or rather, how many of you have developed apps on any of these platforms? So Android, web, iOS, or Windows. So let me know by joining this link here with this code, and I want to wait for your responses. Okay, I'll give it a couple of more minutes. Looks like there's been one vote so far. Okay, so as the votes keep pouring in, so let's from this screen we can see that there's been a good sizable majority of people who are into Android and web development so far. So now this is something that I can use. This is something that I'll be talking about while we go about working on Flutter. So to get started, let's talk about the basics of Flutter. So, what is Flutter? Flutter is a platform that allows you to build build applications for cross-platform devices. So, you want an app for Android, you want an app for the web, you want an app for iOS, whatever be the case, you have a single code base, and that's Flutter. So, what does it do? What is the speciality? It allows you to build UI and components extremely quickly. So there's no competition to it in terms of the speed at which it builds applications. The only competitor that comes close to it is React, that is by Facebook. So now, why is it different? What's the need for us to know Flutter if we already know web or Android or iOS? As we can see, a vast majority of devices nowadays are smartphones. So, and these can be either running Android or iOS. So the other operating systems don't really exist much anymore. And the biggest sizable chunk of population comes from web traffic. So most companies, they end up developing 3 different applications to host such devices. So you have taking an example of Facebook. You have them working on an Android app. They've been working on an iOS app as well, and they have a website. Now, what if they could just now that requires separate teams to handle and work on these products, right? So what if we could have just one single component that does all of this for us, and that's Flutter. Facebook uses React internally, and a lot of other companies use Flutter. So what is the difference between Android development, iOS development, and Flutter? Now, Android and iOS, they follow a form of programming that goes by the name of imperative. Imperative means that before you start working on a UI, you need to create a UI separately and then link it to a particular action. For example, let's say you want a button to be clicked. You need to declare a UI component and then link it in your executable code. Flutter, on the other hand, runs imperative, and that is used to, that is a very, very big advantage for prototyping really quickly, because it allows you to define your UI and the code that executes it in a single frame. So giving an example of how it looks, let me just switch over. To Chrome. Stop the screen and let me share the screen for my other one. Yes. Give me a minute. All right. So now I guess the screen is visible, which tells about Flutter and its declarative UI style. So over here, you can see this is a page of the Flutter documentation. So over here, it talks about how every single application, whether it's Windows, web, or iOS, they use an imperative style. And then this talks about declarative style. So I'll use this example as it's very well thought out and concise. So in a declarative imperative framework, that is Android, web, or iOS, we need to make sure that we create a view that is over here on the right, and then we assign it to a particular component. For example, let's say we have this screen on the left. We want it to click a button and switch over to this screen. Now, in an imperative style, as you can see over here, you need to first select the view, the parent view over here that needs to be red. So we're taking the view B, we're setting its color red. We're removing all of its children inside, that is view C. There are two view Cs here, and there's just one view C here. Create a new view, assign it. That's the type of programming that happens in your imperative style. So any Android native developers or iOS developers, you'll know about this style as it's the basic way to build applications. Now, in Flutter, it's the other way around. Once you create a view, it cannot be changed. It is completely static. Now, this is what is being talked about over here. A view configuration, such as Flutter's widgets, which we'll talk about once we start working on it, are immutable, can't be changed. So in order to change the UI, we need to rebuild the entire thing. So this whole view will be one particular state. This whole view will be another particular state. These two are not linked in any way apart from the transition that will happen. So the only thing we'll be doing is we'll create this view on a click of a button or whatever action we want to process. This view gets destroyed and this view comes into place. That is your imperative method of programming. So now let's head into the programming part of it, and let's work on the basic Flutter applications. So let me just share my screen here, and let's get started. All right, so when you first open up Android Studio, I'll be running through with the basic Flutter application first. So hold up, apparently there's some issue with the screen. Give me a minute. Yeah, give me a minute. Apparently the screen isn't visible. Okay, now it's in. Is it visible now? Okay, all right. Now let's get continuing with this thing. So let's start off with the basic application first. So I'd like you guys to open up your Android Studio and click on Start a new Flutter project. This will automatically appear once you have the Flutter SDK and its components built. So let's get started. So what we're going to be building is a basic application. So click next. We can name it whatever we want. And we just define the SDK path here. For you, it should be automatically assigned. In my case, I have it assigned on a different drive, so it doesn't automatically detect. I need to feed it in. And then that is all about it. Let's go click next, give it a package name. By the way, these two checkboxes here, platform, channel, language support. So let's say you have your application and you want to build it and you want to have segments of it purely in Kotlin. For example, let's say you want to build some services that aren't available in iOS or vice versa. So that's, in this case, you include this kind of support so that this works. Now, let me finish this. Okay, so now this is our basic project here. Now, what I'll first do is talk about this in detail and then proceed to building our own application. So the application that we'll be trying to build by the end of today is a basic to-do list application. But before that, I'd like to explain the nuances of Flutter development. So now let's just set it up on my emulator here so that we can see this side by side. Okay, this is 1 second. So it will be set up in my project structure, SDK location. Okay, let me just do that in the background while we talk about this. So now, in any Flutter application, the main starting point, the code that triggers your entire application is these 3 lines here, the void main function. So as it is in any other programming language, let's take Java, for example. You have a public static void main class, right? So this is the equivalent to that. Every single application starts off here. If you want to run a different app or a different screen, you change this over here. So this my app becomes whatever you want it to be. In the default application, it is it's my app because this is how the entire page is defined. So just give me a minute. I need to stop this share here. And yeah, just a minute. Okay, let me just resume this, and now it should work. All right, so now let's continue with, let me just see if the stream is visible. Give me a minute. There seemed to be some issue in StreamYard, so I'm running into issues trying to display this video. All right, it's on. Okay, so now let me head over to my emulator here, and we should have a demo app over here. This isn't the demo app. So let me give you an example of what we're going to be building at the end of this day. So by the end of this day, or by the end of this session, we would be able to build this basic application that allows you to create your own to-do items. So let's type in inGenius here. And you can see that you can add it in here. You can mark it as done and it'll disappear. This is the basic application that we'll be aiming to build today. So coming back to the code for the basic Flutter application, I'd recommend that you guys run it on your own systems as well, because you can follow along better. So every single, there are 2 kinds of basic classes in Flutter. One is a stateless widget, and the other one is a stateful widget that you can see over here, stateless and a stateful. Now, going back to the document that I shared about imperative programming, right? A stateless widget will not allow any changes in its view once it's created. So the moment it's built, there is nothing that can be changed in it. The only way you can change anything, so anything inside it directly, nested in itself, can't be changed. But a child of it can be. For now, how do I explain that? Over here, you can see that we are creating in the build function. We are creating a material app. Material app is just a wrapper for Google and Apple's material design guidelines. So every single application that we build on Flutter, we can choose to make it in the material design aspect. This determines how the buttons look, how the views are, the color palettes, all that kind of stuff. The title will be the title of the app that's shown up above, or rather in your home screen. Over here is the theme. So the theme determines how your app looks. So what's the primary swatch? The primary swatch is the color over here. It determines the color of the base component. So this blue button here, this color is due to this primary swatch being blue. The visual density again comes back into play for multiple devices. So whether you're building for web or you're building for mobiles or tablets, whatever be the case, you define your visual density. That is the density of the pixels that are rendered. Coming back down, we have the home page. Now, if you've run the base Flutter app, right, you would have seen that it has a counter. Now, in this count, let me just increase the font size as well because I might have an issue viewing this. This should be better. No, wait, I increase this font size at this thing. Hold on. Fly, then go to keynote. Okay, let's make this 20. Should be better now. Yeah. So over here, you would have seen that the basic Flutter app would have a button that lets you increment the counter. Now, I said that you can't change any view, right? Once it's created, you can't change it. So it means that even if you want to increment something or you want to display something dynamically, for example, the way a to-do list pops up, right? There's no way for you to do that in a stateless widget. So how do you go about doing that? In order to do that, you need to create a widget called a stateful widget. As it says, it maintains a list of its state. So it renders components according to the state it is in currently. So this is our root. As this comment says, this widget is the root of your application. So nothing in this root can change. So inside this, nothing can change. But we can create another nested class inside, which allows us to have specific components that change their state. For example, let's say you have an app that you want and components inside it. So these components need to be changed, but the app's theme doesn't need to be changed. For example, let's go into the to-do list app that we're going to be building. You can see that this central section of the to-do lists need to be changed, but we don't need to change the position of this button. We don't need to change the position, the toolbars that we're using at the bottom here. We don't need to change the text that is showing up at the top, that kind of stuff. So that kind of static stuff, right? We define it in the stateless widget here. We can define it in the stateful widget here as well, but there are reasons why we do not do that, which I'll come back to once we delve a little bit deeper into this as well. So coming back here, next let's head into our stateful widget. So over here, you can see that we have a key over here, a self declaration of sorts over here. This is something which I will come into a little bit later. Over here, we're defining a title. And inside here, we're calling a function that goes by the name of createState. So this class, right, this wrapper class, excluding these two lines, the lines that I've commented out right now, this entire thing is a default whenever you are having a stateful widget. So this is how you go about creating a stateful widget. So over here, you can see that it is overriding a function that goes by the name of createState in order to create another class that goes by the name myHomePageState. This might seem redundant. We are creating two classes that do the same thing. We have a myHomePageState here, which extends the state of some sort, and this is the stateful widget itself. Why do we go about doing this? One of the main factors of doing this is to make sure that code is private. So we can't have methods that are unauthorized access our code. So a tip for Flutter, if you want to declare any variable private, right, just append this underscore in front, and that automatically is assigned to be a private variable. As in Android or iOS, right, we don't need to define explicitly saying that it's private. It'll automatically do it. You just put an underscore and it'll identify it to be a private state. So now, heading into this code over here, we can see that it has a counter variable. This is the basic counter that will be shown on your screen when you're running it. And you have a function that says increment counter. This will increment the counter every single time. You will see that it's wrapped in this function that goes by the name setState. So this is something I'll come back to in a minute. Inside the stateful widget, again, we can see that it has its own build method to display whatever you want it to display. So you see that it has an app bar. We're displaying a title here. We are centering it, and we have our text inside over here, which displays the counter. And then we have another action button that lets us increment this counter. And now let me come back to the set state. Now you can't change the state of a variable in an imperative programming language. So what do? We call this function that goes by the name setState. SetState forces your entire view to be redrawn. So that means, let me head back to this diagram here. Whenever I call setState, right, this entire view is discarded and this new view is created. But let's say I want to update this view. Let's say I want to add another C4 here. View C is equal to C4, so another box inside here. So what I do is I just call setState. After I add this element in, it'll delete the old one and create a new one with that new object in place. So that's how a stateful widget works. So that was a very brief dive into the base app of Flutter. So let's get started with trying to build the to-do app, which I'll guide you through as well. So let me just open up the old application. Okay, so you guys can follow along, just create another basic Flutter project. And when we create it, let us start building on this. All right. So the first thing we need to do is we need to create a class that represents our widget, our entire object, right? So that's going to be our main function. So we have our void main run app new to-do app. This to-do app is the name of the class over here. Now, let me just remove this entire component since we'll be doing that in a little while. So inside here, we have a stateless widget. And this stateless widget will be building off of this material app theme. So we have our material app here, home, and we need to call our stateful class. So this stateful class will be built by us now. So let's get started by creating that class to do list extends stateful widget. Now inside our stateful widget, as of now, we do not have any component that it will display. So let us just use the basic override function to create a basic state. So we use the basic function of create state, and we need to create a new to-do list state. Now that is our to-do list state done. Now we need to create a new to-do list state as well, which represents all the objects inside that stateful widget. So let me just add this in here. Just comment this entire thing out as we'll be building it side by side. So class to-do list state. Now I talked about how we could keep this private, right? So we just append an underscore in front of it. Extends. Now this will extend the state of the to-do list. So since it's going to be holding the state of our to-do list, right? We need to just make sure that it extends that class as well. So state to-do list. Now you can see that there's a squiggly line here saying that we are missing a concrete implementation of the build function. So let's get started with that. We can just right click, generate, override methods, and you will find a build over here. Let's go down here. Build context right here. Select that and it'll automatically fill in the code for you. So that's one thing you can do. Right. In order to do that, right click, generate. There are multiple functions that you can. So we need the build function here. So we've got this in place right now. Okay, now what do we do? For now, let's just have a basic text displayed in the middle of our screen. So for that, we got to return a scaffold. Now, what is a scaffold? A scaffold, as the word itself says, it is the structure of the entire app. Every single UI component that you build is based off this. So every single component snaps onto this component. So the scaffold is your base component. Inside the scaffold, you can build multiple structures, and there can only be one scaffold that holds the entire thing. It doesn't make sense to have multiple structuring elements inside a UI, right? You just need one element that gives you the entire layout. So this is your scaffold. Inside your scaffold, the next thing we need to do is create a child that it does. Just give me a minute. Let me just copy the code that was here. Right. And let me just paste this in here. All right. So the next thing we want to do is we want to have, let's first display a text view. So we type in text. Text could be hello world. And that's about it for us for now. Let's close this. Let us close the scaffold. And that is our app ready to run. So let me just run it on our emulator here. Give it a little while to start up. Okay, so meanwhile, let me just explain the components of Flutter. So every single component can be declared in this way. Text, a list view, a scaffold, whatever be the case, you have the function name, or rather the element name, and brackets that follow it. And now you can see that we have our app ready. You can see that the hello world is nested all the way up at the top left over there. Now, let's say you want to display it in the center. Now, in Flutter, in order to align your elements, right, we need to define it. So we need to create another object that holds it in place. So for that, one of the functions that we have is the center function. So inside center, this allows us to center any child that is present inside. So let's say its child is going to be this text view. Paste it in here. Run this. And now you can see that hello world is in our center. This, by the way, is this is a very big advantage for Flutter because it allows us to rapidly prototype. If you were working on Android with this, you'd have to spend a couple of minutes on trying to rebuild the entire thing and push it back up here. On Flutter, it's just run the button, instant results. So that's one advantage on Flutter. So now, how do we go about building our to-do list application? The first thing you want to build is, let's say I want to build the basic UI. I want my app name up at the top here. I want a couple of tabs here. In the middle, I can have a segment that lets me display my to-do list, and I can have a button that lets me create a new one, right? So let's get started on working with that. So the first thing we need to do is, you can see that this entire structure has a kind of a hierarchy. You have a text view up top, you have a list view over here, you have a toolbar at the bottom, and then you have a button over here. So the easiest way for us to align them would be a column because we want them one on top of each other. So let's get started with that. So let me just redefine this and add in a column here. Column. Now, in this column, we're going to have it aligned to, we need to align it. No, let's not worry about alignment for now. Let's just worry about adding in elements. So this column is going to have multiple children. So you can see that this goes by the word of children instead of going child. The first element we need is a text that displays our app name. So first, let's add in our text here. Let's name it O dot, why not? And now, if we just run. So this is our text here. Let's say we want to style. Let's just run this one. After running this, this will look exactly the same. The only thing is it'll show up at the top here. So you can see it's hidden under this uh, time display over here. It says O dot right here. Now we want it to be a little more bold, right? We want to increase this text style. So let's just put style. Inside the style, we need to define the style of it. So another component that Flutter has to define style is a text style. So you just type text style. And inside here, you specify the components. As you can see, Flutter has a lot. It's very, very nested. So you have multiple function calls, each of which represent a single widget. And the widget itself is defined by function calls to other widgets. So it's a very nested structure. So the first thing we want to do is we want to increase the font size. So we type in font size. Let's make it 32. And now let's run this. It's a little bigger, but this text seems a little too bland for our taste. It seems very typical. So now let's add in our own theme, or rather our own font. Now, in order to port in fonts, you can just download any font you want, create a folder by the name of fonts, and then add in all your fonts as a .ttf file all over here. So once you add in your font files here, you head into your pubspec.yaml file. This is equivalent. Okay, so from an Android developer's perspective, this is equivalent to your build.gradle file, where in which you define your dependencies, where in which you add your own whatever external dependency you want, you add it in here. On iOS, it's similarly, you do the same thing. On web, you will have it defined at the start of your JavaScript code. So this is the exact same implementation for this. So over here, we want our font, right? There'll be a line that will be commented by default in your pubspec.yaml, which goes something like this. It says fonts, family, this entire segment. So whatever font you want, right? You create the same thing. You type in fonts, font family. This name can be whatever you want to give it. So it does not need to be the same one that you've downloaded. This is for your internal reference. And then inside here, you define your fonts. You give it the directory name. So over here, you can see that inside my fonts folder, I have a one that goes by the name of light trial. So fonts, light trial, and then I assign it a weight. This weight I'll talk about very soon once I start building it. These are all the different font types that I have: light, trial, demi bold, bold, extra bold. All of these are different types that we'll need throughout this thing. And you can add in any font you want as well. So let's head back to our main.dart file. Over here, we want to select a font family. A font family defines how the font family insert this entire thing. So if I access this font family, I get access to all of these different types of fonts. So let me go here, font family. And then in here, I'm going to define it as anti-pasto. Now, I want to access this particular thing. So let's say I want bold. Its weight is 600. So that is our unique identifier to filter out a particular component. So we go in here, font weight dot weight 600. Now, when you run this, you can see that it is bold and it is still taken to the top, by the way, but it's a little different. Now, according to the app that I showed you previously, the commented code right here defines that. So it is 800. And when we run this, you can see that it's a little more bigger and up at the top. Now we want to align this right around here, right? We don't want it to be sticking to the top of the screen. One way to do that would be by giving it padding. I want to give it a little padding from the top and the left, right? In order to pad an object, there is no way for you to directly type in padding inside your style or your widget. In order to do that, you need to create a separate widget. That is the padding widget itself. This padding widget will have a child. This child will be your text element. So let us copy this and paste this in here. Now this will be, in order to pad this, you type in padding. We want to pad it from the top and the left. So what do? Is we type in edge insets all. This is a predefined function in Flutter that allows you to type in the padding value that you want as a double, and it will reflect it inside. So all as the name suggests, will pad all the way around. We wanted to pad only on the top and the left. So we instead select only, and then let's type in our value here. We want it to be top should be 20, left again 20. Save this, hot reloaded. Yeah, now you can see that it's moved to the left. Now this is one way of doing it. Let's say now what could be the problem with this? If you pad an element with respect to the corners of a device's screen, what could be the problem? One major problem would be that this is dependent on your screen size. If you're using a tablet, this entire positioning would be different. From the corner, maybe there could be something overlapping it. Maybe the screen is a little smaller, the padding elements, the edge aren't properly defined. There could be many myriad of errors that could happen over here. So the best way to go about this, instead of fixing your padding values, would be to align it to the corner after giving it to the padding. So this would make sure that your object is aligned to a particular corner, after which it will be padded. So it makes sure that it's in the corner first before it applies padding. That way you do not have to worry about scaling it to different device sizes as well, because it will automatically take care of that. In order to do this, we need to first create our padding object. So we want it to be, I'd say I want it to be what, 20 from the top and 20 from the left. This looks about right. But I want it always to be on the top left. So for this, I create an object that goes by the name align. Inside align, I specify the alignment. Alignment. So for us, it's top left, right? So alignment dot top left. And then the child for this will be this exact same object. Now, when you run it, you'll hardly find any difference. The same thing. But this is good practice. This is what you should be doing if you are aiming for different devices. So that is how you'd create a basic text. Now we want multiple elements as well, right? We want to have a list as well inside, and we want to have a button, and we want to have a bottom navigation bar. So inside our child object over here, let's head out into the padding object. As you can see, this is a nested structure. This padding object here holds this entire component. And so we need another child that holds the list that we are creating, the to-do list that we are creating. So let's put a comma here, and we want it, let's make it a temporary function that goes by the name build to-do list. So this to-do list is something that we will be building very soon. After that, we need to define we need to define a button, right? So let us head out. We can define the button inside our column as well. But since we are having a button at the bottom right, it's better to use a floating action button. A floating action button is a default library that is available on it's available on iOS, it's available on Android, it's also available on Flutter. This is a button that hovers above every single view that you have. So let's open this up. Inside our floating action button, we need to first create the looks of that button. So let me just go down here, and let me just copy this segment. All right, so now you can see that we are defining a floating action button for this entire scaffold. We are not defining it for the column inside, we're defining for the scaffold. The scaffold itself has an inbuilt function that lets you create your action bar and assign it to a particular position. So coming back here, let me just uncomment this segment out here so that I can start explaining this. So now let's go step by step. Now, in our action button, we need to detect presses. So for that, we have a simple on press. This is equivalent to your on click function in Android. So whenever we press the button, we want it to create a new screen that allows us to add in new items. That is what we are doing over here. So inside here, this part, I'll explain it very soon. But first, let's head into the main part of it, which is this segment here. Over here, we are creating a new to-do item. And this is another component which will come in soon. So let me talk about that in a little while. So you have our new to-do item here. This is what we'll be creating, and we'll be pushing it onto the screen. So this entire segment, a navigator.push. Your navigator is the basic navigation toolkit in Flutter. It allows you to navigate between different screens. So navigator.push allows you to push this new screen on top of the old screen. So whenever you press the back button, right, this screen gets removed and you come back to the old screen. That's what happening. Again, material page route. The transition that happens is according to the material guidelines. That's all that is. Now, then we have our after this we have a button defined. This button is a standard button, so we can theme it, but in this case we aren't going to be theming it, as it's a little complicated for us. So the next thing we want to create a bottom navigation bar. This bottom navigation bar is going to be defining that entire wavy animation that you saw, right? That's what's going to be shown. So let me just copy that and place that in here. As you can see, again, this component is external. So it means that we just remove this. Perfect. Make sure you keep track of the syntax, because Flutter is very messy. As you can see here, building a simple application requires a lot of nesting, and it's very easy to get lost in this nesting. So after every bracket, you need to close. This is all basic Dart syntax. So now coming back to our navigation bar. By default, we have a basic bottom navigation bar, which goes by the same name. So you just say new bottom navigation bar, and that pops up. But this won't look the way that the original one that I built originally was looking. In order to do that, we implemented an external library that goes by the name of curved navigation bar. This can be found on GitHub. Just search up curved navigation bar and you can find this exact same component. All we do is call that dependency, put it in here, and then we define its shape, size, color, whatever we need it to be. So here we're defining it, the background color of it to be white, the color of the items inside to be black. Inside it, we're creating icons. These icons represent each component, rather each tab that we can select. So let me just comment all of this. We have our scaffold built and ready. Now you can see that it is giving me a couple of errors here. One is this method isn't defined. So for now, let's skip this. And inside here, we don't have our storage defined. So let's just cut this out and keep this for later. So now if we run this, this is what we get. We have a button here. You can see that this button has no icon in the middle. That's because we haven't defined any icon inside in this way. So let's just press enter, icon, or rather, what's the thing called? It's called Tooltip from my, yeah. So we go here, let's define a child for it. We need an icon. Again, as is typical with Flutter, you have another class that it nests into. So icons dot add. So this is the plus icon. So we want to display a plus icon inside. Let me open my emulator here, hot reload this, and there's a plus symbol up here. So right now, when I click the plus symbol, you can see that it creates this activity. This activity has already been created at the bottom. That's why it's being displayed. Otherwise, if you click this, nothing would happen. And the bottom navigation bar is implemented. This is a basic library, so all of this is predefined that comes along with it. So the next step we need to do is we need to create this screen. When you click, we need to create this screen as well. So this screen again, let me go down here. Where is that to-do list? There it is. Here is our to-do item. So coming back here, again, this is a different class. Again, we are having an extended stateful widget. We are creating a state, and then we are extending the state. Inside the build function, let me just open up the screen here. You can see that we have another column. Inside the column, we have our padding, top 20, left 10, aligned to the top left. We have an icon button that lets us navigate back. So this button here, you press back, you go back here, press plus, you go back here. So that is one element, that is our align element that works for this. After this comes this entire big text box that says create new text. So again, over here, padding, we want it to be padded from the top and the left again 20. We are aligning it to the top left again. Inside it, we are creating a container. Now, why do we need a container? Let me give you an example of what happens if we remove this container. We could just have a basic text view as well. So let's just remove this. And let me run this. Everything is in single straight line. But I want it to look that way. I want it to have a fixed width. How do I go about doing that? In order to give any element a fixed width, we need to give it a container. We need to nest it. We need to nest that particular item inside a container. So here in this container, you can see that I'm assigning it a width of 200. And then inside it, I'm defining my text. So when I hot reload this, you can see that it's now forced to fit into this new area. That is our text component done. After that comes our edit text over here. This allows us to put in whatever text we want. So again, for that, we are defining some padding. So from the top and the left, again, 20. 20 is this 20. This number isn't a random number. This is the ideal guidelines as given by material design. So 20 pixels is the best distance, or rather the most optimal distance for maximizing your screen space and maximizing user experience as well. So your padding is for 20. You have a child that is a text field. What does a text field do? A text field allows you to enter any text. So inside here, we can see that it has this field that says on submitted. The on submitted is equivalent to your on click as well. So whenever you type your element here and you click the tick button, on submitted is called. So over here, you can see that I am adding it. I'm adding the value that I get from this text. So whatever text I enter is going to be here. Then I add it to my function that goes by the name add to do item here. Add it in. And once I add it in, I am popping from the navigator. So that removes this screen altogether. So if I type in something here and I click tick, this would pop me off. But it does not, because we haven't defined our add to do item. It's currently getting stuck here. If we check into our logcat, it would give multiple errors saying that that function isn't defined. So if I go down here, yeah, these errors, right? These are random errors that keep occurring. So one of these is responsible for our particular action not happening. It's not popping off. At the bottom, you would also see this tiny component that says decoration. This decoration is what shows up inside. So when there's nothing inside here, that's what I want to show up, a task name. So again, there's another class for it by the name input decoration. Input decoration defines how your input is decorated. So you have your hint text, which shows up inside here. You have the hint style again. I want to use my font, give it a size, give it a font size. And you can see that this decoration by default has a padding. Some components have their own internal padding. Some components do not. So that's something you need to keep in mind. If a component does not have padding, you need to use an external padding widget. So that is your create new task screen done. There's no functionality as of now. You can see that even if I type in anything and if I click tick, there's nothing that shows up here because I'm not doing anything at all. So let's go back here. And now let us try to build this component, this to-do list. So in order to build our to-do list, we need it to be a list view of sorts. We need it to display containers in a tile. So for that, let us head down here and let me uncomment this tile segment. Over here, you can see that this is our to-do list. Let me, to-do list state here, hold up. Perfect. To-do list state is created. Let me remove this. So now you can see that there's a to-do list state here. This to-do list state again is giving an error saying that its build function isn't called. So we got to define that as well. So let us find the build function that we have here. So in our build function, we wanted to display a list right now. Let me just comment this out. We wanted to display another element inside. So this element is going to be nested again. So we want it to have its own hierarchy. We do not want it to base it. We don't want to base it off the existing hierarchy. We want it to look independent. For that, we're defining another scaffold here. Inside the scaffold, again, another column. This column will have multiple elements. So the first element we have is our padding. So this is what's going to be showing our entire text view. This entire text view that shows up here, this to-do part. This part, we want it to be built dynamically. We don't want it to be built statically. So that is why we're defining it inside this new thing. The previous one was an example of how to build this basic UI. So then we have our text here. We have our padding assigned to it. Then inside here, you'll find this peculiar function that says expanded. And its child is this same function build to-do list. Now, what does this do? This build to-do list is a function that lets us build our to-do list as shown over here, as we showed previously right over here, up above. But what is that expanded keyword that is following it? Expanded allows you to fit the available screen space. So by default, it will automatically take this entire segment. So from here to here, and it will fill it all with your to-do list components if they exist. So that is a very big help for us because it doesn't force us to specify a width, doesn't force us to specify a height, anything of that sort. And that is why we use this expanded widget. Again, the basic floating action button, the bottom nav bar, all that kind of stuff. So that is our to-do list state built. So what we're going to do is first, let us remove the dummy class that we created here. Let me minimize this and comment this out. And this is our to-do list state complete as well. So that was our basic UI again rebuilt. Now we get started with the list. So you can see the build to-do list function here. When we go up top here, we can find this commented code that says to-do build the whole list of to-do items. So the first thing we're going to do is we need to keep a track of, we need a list of all the items that we're going to display, right? So in order to do that, we first need to create a function that returns a widget. As you can see, we are creating we are giving it a child of build to-do list. A child can only accept a widget. It cannot accept any other return type. So it needs to return a widget. What is a widget? A widget is any of these components: a flat button, a scaffold, a padding object, a text object. Any of these things is a widget. So what we're going to do is, again, widget build to-do list. This will let us build a to-do list item. So for now, let us assume that we have a list of all the items. So let us create a variable by the name of to-do items. As you can see, is done up top here. It's a list of strings underscore to-do items. So this holds the list of all the strings that we have. So that is going to be shown over here. We have our to-do items.length. We're checking if the length is greater than 0. If it is not, we wanted to display a text saying that none or whatever, right? So we're just checking the length over here. And then inside here, you can see that if its length is less than or equal to 0, we are giving back nothing. So let me just prototype this for now. There's an error in the code here. So what does it say? This function isn't defined. So yeah, let's just comment this out. Any other error? One more error over here. Says that storage isn't defined. So we just throw this out for now. And we run this. You can see that none shows up here. That's because there is no component inside. The moment we start populating it with components, it starts showing up as well. So let me just undo those items and let's continue with this. So inside here, while we have, you can see that we have a function that goes by the name of Listviewbuilder. This is another function that automatically builds a list view for you with given components. So here you can see that these, by the way, this item builder, context index, all of these are predefined functions. So you don't need to worry about this. What this item builder does is, given a context, it returns the index of all items. So let's say we have 3 elements. We want to build items index from 0 to 2. So we need to make sure that this index is always less than the length. Otherwise, we could have multiple elements that have no body. So we could just end up creating an infinite list of elements with no objects inside it. So that is why we're checking if the index is less than the length, after which we are returning a build to do item. Inside this list, we need to have an element that is built every single time. So for that element, we need to define the name for it. We need to define the index at which it's sitting. So a build to do item, again, this is a custom function. This is what we'll be building right now. So a build to do item, we are going to take the string from a particular index, and we're also going to pass in the index as well. Otherwise, we're just going to return null. No, that is our build to do list done. Now, the next thing we need to do is building the to do item that we have. So over here, this commented code allows us to build our to do item. So let me go from the inside out. Over here, you can see that we have a text that displays the text that we get in. So you can see that inside this function, we are passing in a to do text and we're passing in an index. So I want to take a to do text and then I want to put it there. The split function comes into play very soon when we start talking about file management in Flutter. For now, let's just ignore it. Again, we are specifying the style here. We're giving it a padding. Now, if you would have seen the previous example that I have, I didn't take a screenshot of it. So in that example, you could see that it had a rounded corner. It had a rounded border and it looked like a card. So that's what we're doing here. We're creating a card. We're giving it a shape of a rounded rectangle. The border is going to be circular. We have padding in here, giving it a specific type of padding. And we're wrapping this with a container. The reason we're wrapping this with a container is because we want all of those list items to be of a fixed size. Let's say one of your to-dos is very small. We can't have it being a tiny segment here. Or if it's very large, we can't have it being excessively large and fill the entire screen. We want it to be a fixed size. So that is why we are defining container here and giving it a height and a width. Now, in the example that I showed, whenever I clicked on that tile, right, it was giving me an option of marking it as done. For that, there is no on-click method. So let's say we want an on-click method for it. You can see that there's no hint for it. There's no on-click that shows up. So in order to do that, we need to wrap our item in a gesture detector. A gesture detector detects any kind of gesture on top of its child. So we can have multiple such functions. So you can see that there are many functions on double tap, on force press, on horizontal drag down. So there are multiple gestures. If you drag your screen down, maybe you can have your refresh called. Maybe you can hold it for too long, you can have it deleted or whatever you want it to be. One of those functions is on tap. Inside on tap, we want to create a dialog box that removes that particular item. So again, a custom method here that says prompt remove to do item. And then the child of this gesture detector is the entire container segment. That is our to do item built. The next thing we need to do is we need to build this function over here, this prompt remove to do item. If we go up top here, you can see that I have it built and ready. What does this do? This shows a dialog. If you have experience in Android, you would know that there's a full-fledged alert dialog dot create, and it keeps going. It's a pretty lengthy piece of code. In Flutter, on the other hand, in order to show a dialog, you just type show dialog. That's it. It'll automatically take care of showing the dialog with a particular size, shape, color according to the platform. So here we're passing in the context of the entire app. This builder again comes automatically defined. So builder, we're passing in the context again here. Inside here, we are returning the alert dialog. We are going to use this function shows a dialog given a dialog, but we need to give it a dialog so that it can display it. So here you can see that we have alert dialog. After alert dialog, we have inside alert dialog, we want to give it a shape of a rounded rectangle because we want it to look pretty neat and modern. So we have a rounded rectangle here. We're giving it a border radius of circular. We're giving it a title, mark as done. Now we need every dialog will have will have buttons that allow it to do certain options, right? You can cancel it, or you can mark it as done, or whatever you want it to be. So that's what happens here. Inside actions, you define a list of widgets. So this first widget is a flat button that says cancel. Whenever you cancel this, I just want to pop that dialog off. I want to make that dialog disappear. A second button will mark it as done. When I press this, when my on press happens, I'm gonna remove this to do item, and then I'm gonna pop that dialog off. Again, the remove to do item. When I come back here, you can see that I am removing a to do item here. This again, I'll come back into place here. For now, if you have a basic static list, so let's just give it a list saying that hello, and then let's add in world here. And whenever I want to remove an item, what I'll do is I'll call set state. Set state is a function that allows you to set the state of your object by forcing a rebuild. So what we're trying to do is we're trying to, in our to-do items, we're going to remove the item at the particular index. And that is our code done. Now we have a predefined list of to-dos, and whenever we tap on them, one of them gets removed. So let me just check for errors here. Again, this component is something I need to cut. Paste here because this will be done soon. Let me hot reload this. This would require a fresh reload because there are statically assigned variables. Yeah. So now you can see that we have this card over here. You can see it has the rounded borders. You can see that it has rounded borders. It says hello here. It says world here. Now, when I click on this, the alert dialog with its rounded corners and the two buttons, mark as done or cancel. When I cancel, nothing happens. When I mark as done, that particular component disappears. That is because your build function is called again to redraw the entire thing. And by the way, this list automatically. So the advantage of a list view builder is it automatically takes care of the size and rebuilding elements as and when changes happen. All you need to worry about is you need to make sure that your list of items is always up to date. That is it. So now this is our basic kind of list view that lets us display stuff, right? Now we wanted to save. We want to save this data. One way to save data is by using something that goes by the name of shared preferences. So let me open up Flutter's shared preferences elements here. So shared preferences Flutter. So this is one component that allows you to write key value pairs of data for simple data. So you can see that it's only for small amounts of data. So let's say you want to hold maybe keys, users, access credentials, or something of that sort specific to your app. It's a small amount of data, and it's going to always going to exist as long as the app exists. So in that case, you use shared preferences. But in our case, in a to-do list application, you need to make sure that the data is available. It's going to be a lot of data. What if you have like a massive to-do list? What if you have a lot of components in it? Let's say you want to attach an image, or you want to attach multiple files. So in that case, you can't use your shared preferences. In order to do that, we need to access files. We need to directly access files. So how do we go about doing that? The first step would be to create in your pubspec.yaml file, you need to import this dependency that goes by the name of path provider. By the way, you would have seen that for every single component, we are importing dependencies. File storage is a basic part of any Android or iOS, even web development. But we don't need to specifically import packages because they come predefined. But in Flutter, we need to import these packages. Now, you can keep this point in mind because this is something we'll come back to talk about in the later stages. And this is a very crucial point that you need to keep in mind when you develop Flutter applications. This is a big drawback of Flutter. So coming back to the code part of it, we import our path provider. We create a new class that handles our data. So over here, you can see that inside my lib folder, I've gone here, new package, inside my new package by the name data, I'm creating a file storage. So this class file storage, all of this is based off the template that is there on package provider's basic site. So let me open that up here. And you can see that an example for this would be wait, this is not package provider. Package path provider. Example. Not this, hold up. Files in Flutter. Nice search. All right, so read and write files. So this is just based off the basic Flutter documentation that we have. So over here, you can see that there's a predefined code over here that lets you access and increment a file. So remember the basic counter app that is built by default? It's just that, but with a counter storage instead. So you can see that inside here, we are creating a storage, this entire class, right? This class storage path up till here. This is what we've copied and we've adapted for our own purposes. So I can't go into details with explaining all of these single components because that'll take way too much time and we still have quite a bit to do. So let me just go into the part that is critical for us. So here you can see we have a get local file method. By the way, these are predefined methods, so you do not get to define them. So you just call this method, add in your own file. So inside here, I want a file with the path of todos.txt. That's going to be my file name. Inside my file, whenever I read a to-do, I want to I want to print out a list of to-dos, right? But in a file, how would I do that? If I'm saving a file, let's say I have a to-do with the name. Let me mimic a file inside over here. So my to-do list one would be, let's say, inGenius. And then in my to-do list two, let's say I have amigos. How would I differentiate that these two are two different components? In my file, I can have one way to do that would be to have every single to-do assign a few different files. So here we can maybe pass in an argument that takes in a dynamic file name. So for example, whenever you name your to-do, right, the path name will become, this will be replaced by your to-do's name, maybe the first 4 characters, something of that sort. Another way to do that is to add in characters that can split it. Now, this is not a good approach. This approach is very quick. That is why I've chosen it for this demonstration, but it is not ideal because by that, it means that you have characters that are restricted. That means you can't allow your user to access them because it'll break up, but it'll cause errors in your program. So in this particular case, I am splitting all my to-dos with this tilde symbol. So every single to-do is separated by a tilde. So in a file, I can have multiple lines of to-dos and all of them are separated by this. Every single time my file reads this line, right, it'll split this into one to-do. This is the second to-do. This is the third to-do. This is not good practice, but this is something that's really quick. So over here, you can see that I am getting the contents of the file. I'm reading it as a string. Then you can see that I'm splitting this at every tilde. And then I am returning this to do. If I'm not able to access this file, I'm just going to return list, an empty list. And whenever I want to write my to-do to a file, right, I'm just going to pass in a string and I am going to pass in another is complete. This string marks whether a to-do is complete or not. So let's say you want to check off a to-do for the day. Let's say you finish studying or whatever be the case. You want to mark it as complete. So in this demonstration, I'm storing it as a string as well inside the same file. So you can see that over here, I'm again getting the file. I'm calling the local file method. So you can see here, get local file. Calling that method. This is another debug print statement. And then I'm returning the file I'm writing it as a string. So I'm write as string. I'm taking the to do. I'm appending it with the caret. This caret, this symbol allows us to split our text further into is complete and not complete. How does that work? So let's say I create a new text, right? Let's say inGenius. Or let's say compete at inGenius. I want to mark it as false for now because I haven't done that yet. So how do I separate? I can just write false here. But how will I differentiate between that? In order to do that, I'm adding this symbol in place again over here. Adding the caret symbol here, and I'm typing it false. This means that in this particular to-do, it hasn't been completed. After which it's separated by this character, and let's just type something else here. And let's say this is 2. So this means that inGenius is an incomplete to-do, and pop is a complete to-do. This is just something that I've come up with at the top of my mind. So this wouldn't be the best practice that you can do, but it is an option. But you need to keep in mind that if at any time a user uses this symbol inside the code, it's going to break your app. So this is bad programming practice. Now inside here, I am, is complete. I'm appending it with this tilde. And over here, I'm writing it with the mode. This mode, a file mode append. If I do not add this file mode, it will overwrite the file. So whatever was stored before is cleared and deleted. That is why we want to append it. And that is why we have this tilde symbol to make sure that we identify between different to-do lists. So that's our file storage done. Now, coming back to our main file here. Let us go to our new to-do item inside here. Whenever I create a new to-do item, right? Whenever I click the plus button, I want it to start up this new to-do item class. So going back into the new to-do item here, you can see that inside this padding, there was the function that went by the name add to-do item. This add to-do item corresponds to this function in file storage, which is, wait, not here, hold up. Oh, sorry, it's in the to-do item state. So here you can see that it's add to-do item. If the length of the string that I pass inside here is greater than 0, I'm going to access the storage and I'm going to write to-do. Write to-do is what? Again, the same thing here. I'm going to write it with the task. By default, it's false. Whenever you create a to-do, it's always going to be marked as incomplete. So that is our to-do creation done over there. The next thing we need to do is go back to our main function here. We need to make sure that we pass in a single instance of this file storage. Accessing files is a very, it's a computationally intensive task. Accessing files is slower than accessing RAM or any other thing, and that's a known fact. So how do we go, if we want to create a very responsive application, right? We can't have multiple file accesses at each stage. So we can't have the main function access its own version of the file storage. We can't have the to-do item class access its own version of the file storage, and we can't have the file storage itself have its own version of the file storage. In order to give it one single component, what we do is in our core creation, in the core function that we build, in the core function, we define a storage. So for that, let me remove this and let me uncomment the old class that I had created, which is this one. You can see that I have assigned a file storage here. It's the same thing as before, but the only thing is that these two lines are here. The first line is defining a storage type. This storage type will be used by every single child of this particular stateful widget. And this is a key value map. So this is for internal reference. So when the Flutter VM runs your application, right? It makes sure that your key and your storage is mapped. So this is just creating a dictionary. In Python, a dictionary, that would be the closest equivalent to this. You have a key and a storage, you're mapping it, and you're using it throughout your entire application. Now, when I create this application, right, when I first create it, so I create it here, void main starts up my application. To-do app is the base stateless widget called. A stateless widget cannot change. That is the perfect place for us to store our storage, because the storage can't ever be recreated. The only time it will be recreated is someone closes the app, which is perfectly normal. So what we do is we pass in a storage. Storage, by the way, this shows up here because we have our file name defined here. If we make it, let's say store one rage, this becomes store one rage here. But we need to define it. So, and we need to rename this as well over here. So let's just remove this. Let's remove this. We have our storage. We want it to be a new file storage. So file storage or whatever is your class name here. So my class name is file storage, so I'll be using file storage. So that is our list passed. Now let us remove our dummy data here. And we need to change this as well. We need, whenever we remove a to-do item, we need to make sure we call the write to-do function so that we mark it as complete. If it's marked as complete, it'll disappear. So that's what we're doing. Again, we are write widget storage dot write to-do item of index, and we are making it true. And then over here in my to-do items dot remove, I'm removing it from the local list that I have here. This is the old function. This is our build to-do function. And now that is our base code done. Let us run the app. Let's make sure we don't have any errors here. All right. Let's run the app. Okay, so right now we have no to-dos. Let us add in another one saying inGenius here. When you click the tick, okay, no, we did an error here. So let us go back into our logcat to make sure that we have everything running as intended. This has been active for a long while. Okay, this is running into, this is not our application's error. This seems like there is an issue with, okay, let me just head and jump back into a previous version. This is where your, another example of where JIT comes into handy, because you can directly just access your file and revert it to your old history. So let me just go back to local history, show history, and we go back to the file that I created yesterday. So let's just revert this. And now if we run this, yeah, we're back to the old data that we had. So let me add in over here another, click the tick button. You see that the widget disappears and we have another item added here. Right now it seems to be overwritten. There seems to be something that went wrong in the middle. So that's something we need to be careful of. So that is your basic to-do application. So when we select this, we can mark it as done, and it'll automatically be deleted from the database. Now you can see that even after I've marked this as done, right, it's not disappearing. It doesn't go away. That is because when we fetch it from the file, right, it's saved permanently. We aren't calling, so let's go back here into our build function. You can see that when we are removing an item, right, we are writing it to the to-do, we are removing an item from our index, but the issue is that we do not get to update the entire list. We need to make sure that the list is up to date. Which list? The list from our storage, the list that we have used to store the data over here, this entire area. In order to do that, we create this function that goes by the name of update list. This update list lets us, as you can see, we are accessing the storage. We are reading all the to-do lists. Since it is an asynchronous function, so you can see that it's an asynchronous function, we need to wait for it to complete. So hence this then clause comes into play. Once we complete it, we get this to-do list. Then inside here, we call set state. We take, for every item inside here, we again split it into completed and non-completed using the basic split mechanism that I designed a little bit earlier. Then going back here, we are checking if the length is greater than 2. This again is a little bit of code that just is there to format the string into a particular format that we want to display. We can't have it display the entire string, right? We want to display only the part that is relevant to us. So we have our set state called in here. And then at the end, we are assigning this old list with the new list. Now, this list is already defined in this code, but it does not work properly. And that is because in our code, we aren't calling it at the right time. We aren't updating the list every time we need it to. For example, when I press this and when I mark it as done, right, it doesn't cause an update at all. In order to do that, one way to do it is by calling your, and the name of our function was update list. We want to call update list every time we build it. So that's what's happening here. So every time we build it, we are calling that function, and we are making it run. But this comes with a very, very big drawback. This will be forced many, many times per second because this build function is called very frequently. The whichever OS you're running on, Android or iOS, is free to call this function as many times as it wants. Whenever it wants fresh data, it'll just ask you to rebuild it. But it also allows us to update it every single time. This is very bad programming practice. You should not put your update list function inside here. A better way to do this would be to create a callback which allows you to notify an observer every single time an alert happens. So let's say you update your to-do list. You want it at that moment to update your entire state. That is something, again, it's a little advanced, so I can't cover that now. But for now, we are taking this build state. Keep in mind, this is very bad programming. This is the worst mistake you can do in Flutter. Do not define or call any function in your build function. The only thing you should do in your build function is return a scaffold. You should not do anything else. So all these, there are many points that I've talked about throughout this code, or rather this coding session. So those points will come in handy for you when we have the quiz later on. So that is our to-do list application done. Now you can see that there are a lot of functions that are still left. For example, I'm marking it as done, but this isn't complete. It doesn't disappear. Let's say, what if I want to have a checkbox up here that makes it that I can show as marked as complete or whatever? That's not done. This tab switching mechanism, that's not completed as well. So these are some things that you guys can work on as well. If needed, let me know in the comments as you view the video if you guys need this, and I'll put this up on GitHub so that you guys have access to this repository to work and play around with. So that is our to-do list application complete. Now, just a minute, let me head back to my screen. Okay, so give me a minute. Let me just switch over to a different screen for now. Okay, so let me give an example of one application that I've built recently that can demonstrate the full power of Flutter. So let me start the screen share again. All right, so inside here, let's minimize this. Head back out. So this is one example of a app built using Flutter. So again, we have our basic list up top. We have our tabs up here with different views corresponding to it. We have a list of all the books that we can see. We can have a segment which has, when we click on this list here, it shows that book, a note, overview about all these different segments. We have a scrollable sheet up here that lets us view all the elements inside our library. Tuck it back down, a plus button that lets us create a new book, different kind of stuff. So the advantage of building this in Flutter is, just give me a minute. Yeah, so the advantage of building this in Flutter is that I build it on Android, but I can make it run on web and I can make it run on iOS as well. So this becomes a cross-platform app that I'm building. Now let us talk a bit about, now with this I stop the entire screen share part of it. So this is where our application building is done. Now comes the top part where we talk about the different components, the pros and cons, and certain points that we need to keep in mind while building Flutter. So a couple of pros with Flutter is that it, as shown, is very quick to build. It is very easy to prototype an application. So for a hackathon in particular, right? For, let's say, for example, for the inGenius that's coming up, it is very easy for you to build very good looking UI and functionable components very easily. Compare this to Android. This would take you quite a while because you need to build your UI separately. You need to build your code, Java code or Kotlin code separately, and you need to link them together. Whereas Flutter, you have your UI and your code defined in a single part. Another thing is that you can build for two platforms at once. What rather than two, you can build for every platform. You can build for web, you can build for Android, you can build for iOS, and that's a very big plus. And another thing is that the packages that they have. Remember the package that we've built. That is our the curve navigation bar package that we used very recently. This navigation bar package allows us to allows us to implement this entire curve navigation without worrying about any form of programming, because it's just a plug and play solution. Even the file storage. Let me open up this part with the file storage. Let me share my screen. Yeah. So over here, you can see that accessing a file is pretty straightforward. The only thing I need to do is import this plugin and just copy paste this code. Whereas if I wanted to do the same thing in Android, it would require me to do a lot of stuff manually. I need to find a file. I need to first get permissions to access the file. I then need to find the directory in which I am going to reside my files in. I need to read the file. I need to define a file. I need to define a function that can read the file. All that kind of additional head work is there. And even in iOS, it's the same thing. Whereas in Flutter, it's pretty straightforward because this package is built in such a way. That is one major advantage of Flutter as well. But this also comes with a big drawback, which I'll talk about very soon. Let me just go back to my stream share. Perfect. So let me just stop the screen share here and continue talking about the cons of it. Now, every single component in Flutter, right, it's built for both platforms. Now, there is no way that the Flutter or the Google team can ever build components for every single segment that is required for a camera, for file pickers, for file accesses, for fingerprints. All of these depend on packages, the one similar to what we saw previously. So these packages depend from other users like us. It's up to us to build such functions. So there are already a lot of libraries available, but this is very dangerous, or rather this is a very big dependency on other developers. That is another major point to keep an eye out for. Another thing is that if you want to access platform specific features, for example, in Android you can run a background service, right? But in iOS you can't do that. There is no way for you to run a Flutter service reliably. There are implementations or packages which let you do it, but it's not reliable as compared to running or creating your own app from the ground up with Kotlin for running background services. Similarly, in iOS, you have the health kit. Health kit keeps a track of all the health data. Android doesn't have that feature yet. It has something similar, but not exactly. So these kind of features are platform specific, and that's what we got to rely on. Another thing we need to keep in mind is that Flutter has a lot of it has an alternative that goes by the name of React Native. That's by Facebook. The difference between Flutter and React is just this. Flutter uses Dart. React uses its own React language, which is based off JavaScript. So for a web developer heading into mobile development, the best way to head into it is by jumping into React, because it allows you to build applications extremely similarly to how you would using JavaScript. Okay, and that is all I have for the seminar today. Hope this was an informative session for you all, and nice having you all here. See ya.